welcome to Roundtable Talk number 5, Nested Transactions. My name is Denicia Butte, Community Content Lead at the Cardano Foundation. These Roundtable Talks are designed in an educational way to help and inform and empower the community, Cardano community. We also discuss a range of topics, like, for example, nested transactions. So today with me, we have Polina, we have Will, we have Andrew and Michele, experts in this field. But first, my co-host, Matus, how are you doing?
Yeah, I'm good. Thank you very much. Yeah, shall I take over from now,
Sure.
basically? Okay. So there has been a tweet that I remember reading a couple of weeks ago or days ago, 15th of October, where basically Andrew Westberg mentioned that he doesn't really want Peras on Leios, at least not immediately. We can go into the details later, but actually would prefer validation zones, which actually I believe have been renamed to nested transactions, CIP 118, relatively recently. Of course, I will let Andrew speak whether he really doesn't want Peras on Leios at all, but I would not assume that. I just think it's a matter of prioritization. I don't. That would be kind of like not impossible, but there are some thoughts that I also have in this area. But let's not go there. So basically, I think more or less we want all of those things. But it would be really worth, first of all, for Andrew to express a little bit his perspective into this, maybe for a couple of minutes, 2-3 minutes, and then we can dive into what those validation zones or nested transactions is. We can also briefly talk about Leios and Peras, because there are some people that are listening to us that perhaps do not really know what is behind those terms. But we have here experts mostly from the validation zone CIP, if I'm not mistaken. And on the Leios and Peras, I can also comment a little bit, I think. Yeah, so I would suggest if Andrew, you can briefly elaborate on that. That would be appreciated.
Yeah, so first and foremost, thanks for having me on. I do want to say that Twitter is not real life. And so when I tweet on Twitter, it's sometimes to get a rise in a reaction, so also known as engagement farming. And that was kind of the point of this tweet, was to say there was a lot of talk in the community going on about Peras and Leios, and I felt like nested transactions were not kind of getting their due. And that's why I tweeted about that. My perspective is, like right now, I feel like DeFi on Cardano is a little bit stuck, where everybody has had to re-implement the wheel with creating batchers all over the place to settle transactions, where somebody goes to a dApp, they put in a transaction that specifies their intent for what they want to do, but then it's up to some batcher or third party or whatever to take that and then complete their swap, their, providing liquidity, whatever it is they want to do, simply to get things onto the blockchain in order. And that's all I was really getting at with there. I do like Leios. Peras, I'm still not so sure about. But that's where I'm at right now, is I think there are some good things in nested transactions that may get us away from batchers. I still have some concerns about nested transactions myself as well. But sometimes if you want to start a conversation on Twitter, the best way is to be controversial. So.
Okay, I understand. Well, let's maybe talk about a little bit basics of nested transactions. So let me start by saying that obviously Cardano is a fully deterministic system, or at least maybe fully deterministic is a strong statement. The user does not have to pay for failed transactions. And obviously in other account-based systems, this is not the case. And that's why They don't need to have badgers for AMM access and for some other use cases. Excuse me. But when I first started to read the CIP 118, and I must confess it's very technical, it goes very, very technical very quickly. I kind of like was hoping that in Cardano we can eat the cake and have it too. And what I mean by that is that perhaps we can have a system, because we have kind of like two-level validation, phase 1 and phase 2. Perhaps we can have a system where we won't be charging user for failed transactions, but at the same time we won't have to have badgers, for instance, for AMD access and for bubble fees. Excuse me. And for bubble fees, we will also we will be able to implement them with that CAP, although it might not be the only way to implement bubble fees.
But Matus,
Yeah.
if I may interrupt you just a moment, because remember we have here two experts. These are the
Point. I wanted to point to the experts.
Yes, exactly. But maybe it's worth really like allowing them to really express and explain what really nested transactions are as a
exactly.
basis. Yeah. So it's I'm just gonna look towards Polina and Will. Which one of you would like to start first? Sure.
I think I'm gonna say a few words. So thank you so much for having me on here, both of us. All right. So what are nested transactions? So some of you may recall a while back there was a research project called at IO called Babel fees, and so this has been a long time coming. And so the idea of Babel fees is that you can submit transactions that do not spend any ADA and don't pay fees on ADA, and they will eventually make it on chain. The nested transactions CIP is the evolution of that idea of the Babel fees idea, and with an extended scope and with a bunch of revisions to hopefully towards actual implementation of this idea on Cardano. In a way that still supports the core idea of Babel fees, which is publishing non-ADA transactions. And so this allows non-ADA holders to have the ability to use Cardano, which brings a lot of opportunities. And so this, just a quick note, the CIP kind of talks about an AGDA specification, which is the design of the system, of the system feature, which is done by me, and the ledger implementation prototype, which is like how do you actually make that work on the Cardano ledger, which is done by Will. So how does this, how do Babel fees work? So you can't use non-ADA tokens for doing system things. So that means that you can't pay fees, you can't use them for min UTXO value, you can't use them as collateral or anything like that. There are good technical reasons for that. So we had to figure out another way to do this. So this the idea is in Babel fees and nested transactions, which was also validation zones. It's just that it went through several iterations of design, which were different enough that they had different names. So in nested transactions, validation zones, and Babel fees, all of them, other users actually are the ones that cover the missing fees. And that means that they get extra non-ADA tokens in those transactions, in the transactions that don't pay the ADA fees as compensation. So this is kind of assuming that a transaction that doesn't pay fees in ADA is going to have is missing that ADA, and it has extra tokens of other type. So what this looks like is exactly like an atomic swap. So the goal of nested transactions is to facilitate atomic swaps without smart contracts or two-way communication. And we want to do so in a way that's extensible in the direction of other features, such as more general intents, which is also a part of the discussed in the CIP. What does it mean to not require two-way communication, or how does nested transactions achieve that? So basically, non-balanced transactions can't be posted on chain individually. However, they can be posted when they get matched with other transactions where the resulting combination of transactions is balanced. So the way that this is done is kind of like a fire and forget mechanism. So there's no need for users to sign and approve the full batch. So you submit your transaction, and then whoever completes the batch is able to post both of those transactions together on chain. So this is we call this counterparty relevance. So a batch is valid whenever it passes all the ledger rules, such that, for example, the current time is within the transaction validity interval, but also importantly, such that the batch is balanced. Individual transactions don't need to be balanced; the whole batch is. So this has a lot of implications for how things work off-chain. Batches must be created on-chain, so there's no mechanism for communicating incomplete batches on-chain, and you don't submit them to the Cardano system. So this CIP doesn't have any off-chain component. However, it creates a lot of opportunities for the development of such off-chain components. Incomplete transaction batches can't be sent over the Cardano network, as I said, because of DDoS concerns. So if you send a transaction across the Cardano network, it goes into the mempool, and then if you flood the mempool with transactions that might never even get processed, that's not a good thing. So that's why they need to be disseminated separately. Off-chain mechanism will be required to communicate and process incomplete transactions for this reason. Any Cardano community member can build and deploy applications for building and submitting batches. And we expect such applications will be running alongside a node. So the requirement represents an exciting business opportunity, hopefully, for users to build solutions offering services tailored to specific markets. So this could be anything from a whole big DEX production to individually filtering transactions with atomic swap offers, such that you just get to purchase the token that you want, or swap for the token that you want yourself for personal use. So some of the main use cases that we're hoping to target with nested transactions is open atomic swaps, DEX aggregators, Babel fees, which is the original design, and DApp fee and min UTXO sponsorship. So, for example, if you want to engage with a specific DApp and you don't have any ADA, the DApp you might get sponsored for using that DApp. So yeah, basically that's kind of the gist of nested transactions. The other stuff in the CIP is are examples of how to extend this idea into more use cases. So I forgot to mention kind of an important aspect of this. One of the features in the CIP is that a transaction can require that a batch in which it gets put runs a specific script. And this script has to validate, just as scripts do. However, this script is able to see the entire batch. And this is kind of like a version of quite general idea of intents that's saying, okay, so I want to perform an exchange. However, when I perform an exchange, it has to be within these specific constraints. So you can constrain what the whole batch does on chain. Yeah, so this is the general summary of nested transactions. Let me know if something was not clear.
No, awesome, excellent, absolutely. I'd love to hear from Will. Will, is there anything that Polina might have mentioned or that you'd like to elaborate or build upon further?
That was very comprehensive, actually. I don't really have anything to add. Yeah.
Well, I have something. I have a question. In life, there's always a price to pay. And my question basically are twofold. What is the price to pay for a user? Are there any prices? Like, will he lose collateral or money if the transaction fails? And the second thing is like, is there any way that we could, is there any remote way to estimate the development cost on the ledger? How complex it is on the ledger? Are we talking half year, 1 year of development, or anything along those lines?
So I guess as for the ledger question, I could not tell you the length of time that it's going to take to develop. However, because the ledger has scheduled hard forks, it will be either one hard fork's worth or more hard forks worth. So it will not. It might be combined with additional features that will be part of that hard fork, which will take additional time to integrate into our design. So we currently, so this is a better question for the ledger team, I guess, is the answer, because we do have a prototype that, if we had a Babel fees era, this prototype could potentially work. However, this is not what will actually go out once to support nested transactions, because again, there'll be a lot more considerations, additional features, integration with new features of other system components, and so on. So yeah, difficult question to answer. As for payments, so I guess the idea is that the off-chain component is going to be fully customizable for the specific purposes that is being used for. For example, DApp fee and Min UTXO sponsorship. That one could assume that maybe the DApp wants to let users use it for free, or like maybe the DApp developer wants the DApp to have wide adoption and just wants to subsidize the use of this DApp and pay the script fees for the transactions, and in which case you don't have to put the ADA into the transaction, or like you don't have to exchange the fee price for another token in your transaction. But of course, in the Babel fees case, the price of the token you're trying to exchange, it should be comparable to the amount of ADA you require in fees, and maybe slightly more, because to pay for the user running the service that will combine the transactions for you, or something like that. Yeah, so it really depends on the use case.
Yeah, there are just a quick question there, because Andrew, Sebastian, can we bring that tweet up again? So Andrew, I mean, I do feel like Polina's explanation is indeed very comprehensive, and learning this, I'm pretty sure that when you posted that initial tweet, right, stating that I don't want Peras, I don't want Leios, I want, in essence, nested transactions first and foremost, you must have had a thought process, an idea. There must have been something that really triggered you or inspired you to really want that.
Yeah.
Can you elaborate or explain that?
Yeah, so Peras is largely, the purpose of Peras is largely side chains, needing faster on-chain settlement. And so Peras is mostly to support Midnight. I think that's where it came from. I'm not necessarily sure that is a community thing to do, or fund. If Midnight is kind of an IOG bled private blockchain sidechain thing, I think they should I'm all for getting Peras done, but I'm not sure the funding for that should come from the community. Leios is all about doing a lot of things in parallel, but for this specific case where we're talking about doing a swap, Leios doesn't really make things any faster for that. Like, it could allow us to have 1,000 dexes at once all swap, but for an individual dex to go any faster, it would not not really allow for that. Now, I kind of want to hear from Michele because he had some interesting ideas, and we've talked offline, not in this meeting. So I'd like to hear some of his ideas for ways forward that he's talked about that aren't necessarily any of these things.
Yeah,
So maybe
please,
I'll just
Michele.
toss over to him.
Yes. I'll try to cover a bit what has been discussed so far. I do agree with Andrew that we are seeing a lot of dApps that are recreating essentially batchers. And for what? First of all, at the time of the tweet validation, so the CIP was very different. And for the complexity of that CIP, I wasn't really happy about it. This revised nested transaction is, in my opinion, a bit cleaner in respect of the validation zones, but still there are some fundamentals problems in my point of view. So the core problem, as Andrew mentioned, is that every app is re-implementing these batchers. For what I saw in the CSP and as confirmed by Polina, the CIP nested transactions, yes, do allow for this kind of incomplete transaction to be fulfilled by someone else, but still all this process is performed off chain, which and as also Polina mentioned, via essentially a process that is on the side of the node. And when I heard it, I said, like, we are discussing batchers. Batchers are a process that are on the side of the node, so we are re-implementing batchers once again. So under this perspective, I don't see how nested transactions are helping validate solving the problem of batchers, rather are incentivizing the constructions of batchers. So we are following back on that problem. Regarding the use cases for which we could use nested transaction, it was mentioned atomic swaps, aggregators, Babel fees, and sponsored transactions. Sponsored transaction and Babel fees are essentially the same thing. The only difference is that the fee is ADA and is not another token. So I would consider that a single problem. And the thing is, we already see solution for all of these applications. Babel fees and with them also sponsored transaction are already implemented by the Fluid team and also the Mint team. Intents in general, there were off-chain solutions that are at the end. We are still off-chain here with the way batch need to be completed. Off-chain solutions were implemented by the Pandora team, if I'm not mistaken. There are solutions that do not require this heavy ledger modification, especially on the data. We are introducing essentially in the transaction body a possibility to include other transactions. So we are making this data definition that is recursive. It's not a big deal, but definitely complicates stuff. And so regarding the aggregators, we already see aggregators. Doesn't mean that they are perfect. I see how batched transaction would help with aggregators, but still is a marginal improvement, I would say. And same for atomic swaps in the thread of CIP 118. So nested transaction, I mentioned that we can leverage other portions of the Cardano node, especially the consensus, which is intrinsically indeterministic. We have to decide between many blocks. We can leverage consensus to choose which atomic swap to perform via what I call mutually exclusive transactions that are already possible without our fork. So all the use cases where we would use Babel fees either are already present or are already possible without our fork and without complication on the ledger. And the main thing about complication is that the more we complicate the ledger, the more there is space for a bug. And one other thing is I'm also worried about two things mainly. The decentralization of a DApp, we have no problem regarding like the network itself, but as we are seeing DApp being built, we tend to see lots of centralization between the design of the DApp, mainly because of this off-chain necessity, whereas we want to try to move most of the logic, I wouldn't say on chain, but the data to make decision on chain at least, and then every user can make independent decision off chain, depending on the data on chain, even if that data changes. So in my opinion, we need to shift our perspective of the problem, not requiring centralized entities batching transactions. This is what essentially the CIP is doing. Rather, having decentralized entities reading data from the blockchain and making decisions based on that data. And so,
So
I'm not
are you
sure.
saying are you
Yes.
saying that nested transaction encourages what, centralization? Am I getting you?
Yes,
Yeah.
not well. It doesn't necessarily force it. Like it's not like if we use it doesn't. If we use nested transaction, doesn't necessarily imply that the application is centralized. However, there is a strong bias in designing centralized applications. If some application wants to adopt something like nested transaction, because of this off-chain component to that needs to match to aggregate stuff. So these are the main reason on why you see opposition on my side. All the stuff that could benefit, we already have or already can be done, and there is therefore marginal. And the other major point is having essentially what is application-specific logic hard-coded in the ledger, which should be instead general purpose. I don't know. I don't know how to feel about it. Regarding this openness of transaction, it has not as much as core development, so not as much as the node itself, but as an application developer, so on top of the blockchain, I see this openness for others to complete transactions as a potential attack vector. I mean, strictly at the application level. So it is additional load put on the developer of an application to be sure that the checks on these batches that are potentially fulfilled by anyone, unless it is centralized.
I'm just curious. I'm curious here because Will, is this something that you would like to comment on?
Well, I suppose the thing that I would like to comment on primarily would be the amount of effort required. I don't want to speak for the Ledger team, but given that I built the prototype on the Ledger, my sense of scale of the development isn't gigantic, and I'm not, again, I can't translate that into an amount of time that it would take the Ledger team. That's up for them to estimate, and obviously to then implement to a production standard, which is not what the prototype was. But on that specific point, it doesn't seem especially complex overall. I can certainly see it going in and sitting alongside other changes, in a batch that will lead into a hard fork. And additionally, in terms of adding significant complexity to the Ledger code itself, again, I see it as more changes rather than a significant increase in complexity. Yeah,
Yes,
that would be what I'd.
Yeah.
Yes, no, I agree with that. There is not. I'm sorry. There is not like it's not that big as a change only as the ledger on the Ledger side. However, it does have serious implication on the application design, I would say.
Yeah, I was going to say the same thing, like downstream changes for everybody to support this in their DApp. It would be a pretty significant effort.
I'd
So,
like to
like,
hear from Polina.
You mean as in like modifying the batchers that exist that combine fully valid transactions to instead deal with these
Or
partial
even-
transactions?
Not just dApps themselves, but anything that indexes the chain. So they would have to learn how to read these new nested transactions and validate them. Because it is quite a big change for them. So anything like Aura or any of the TX pipe tools or Ogmios, anything relying on Ogmios, like all the way down the chain of developer stack tooling, would be a pretty significant change all the way down.
You're right. It would require change in that respect. However, any hard fork any addition of a new feature will require the transaction will be encoded differently.
Right, but it's traditionally we've had changes on the level of this is an array, it's now a map, and this is like a whole big restructuring of everything.
Yeah.
I see Michele here laughing. Michele, why is that laughing?
Yeah, no, because I agree with Andrew here. Like per se, if you were to look only at the code, at the CDL specification, it's not a big change. As I said, it's just taking up a piece of data that is already defined, a transaction, and putting it inside a transaction. So it might not seem, it's not a huge effort if we limit to that. However, it is like we are introducing recursion. It does have a pretty considerable impact, as Andrew said, on the downstream, not only batchers, also on all the additional toolings. And yes, and I don't consider, honestly, this cost including everything, and not only what is strictly on the node. I don't consider this cost worth it compared to what is the actual benefit, considering that most, if not all, of the solutions are already possible.
Yeah, I mean, this kind of it is a re-implementation of stuff that is already possible. However, I think it kind of like makes intents and specifically atomic swaps like first-class citizens on the ledger, so that moving forward, the app development will hopefully be more streamlined and simple using this kind of new ledger feature. I realize it's very hard to, or I realize that it is a non-trivial effort anyway to have existing apps support this change, but hopefully it will be like a more reliable, more formally verified way to support intents and specifically atomic swaps. Is the hope.
I had a question for Polina. You mentioned earlier that the reason we wouldn't do on-chain batching, essentially, of these nested transactions was a denial of service attack. And I can see that where somebody could just flood the mempool with these partial transactions, and then the question is, how long do we keep them around? You know, at what point do we realize it's an attack?
Yeah.
Were there any thoughts to figuring out a way to do that on chain, or was it just immediately the way to do that is off chain with some type of third-party batcher, even if it's SPOs? And does that really solve the problem if those batchers then are also subject to flood attacks?
I mean, as far as I understand, the capacity of the mempool is not meant to support transactions waiting around to have the batch filled. So there weren't any efforts, not on our part anyway, to make this fully on chain. But like the idea was that it's basically runs the service that listens for these kinds of transactions runs next to the mempool, and then feeds, sends it across the network, but also sends it to your local mempool once you get a full batch or nested transaction batch.
Okay, so does it actually use the Cardano protocols to like send them across the network? It
No.
just doesn't keep them in the mempool? Okay.
No. Unfortunately, no. It does not. It also I guess the time for transaction dissemination is very important to
Right.
keep low, I guess. So
If I may-
that was not an option. We were advised not to try to have that happen on chain.
If I may intervene here, what I was proposing also in the thread of CIP on the pull request that I informally refer to as mutually exclusive transactions would be a way to I wouldn't say on chain, but at least in the node fulfill these intents or similar or a subset of intents at least. That is, if in the thread I explained a high level the idea, I wouldn't define it as a DDoS because you can send different transactions to different nodes, and so you are not flooding the mempool. And based to the pool structure, pool first structure of the transaction submission mini protocol, this would not propagate to the entirety of the network. So I don't see it as a problem, and it has the added benefit that transactions that are invalid are automatically dropped. So at least one of those transactions that is mutually exclusive, and since it does pass phase 1 validation and potentially also phase 2 validation, all those transactions pass the validation, we are sure that at least one of those transactions is valid. So we are sure that at least at a point in time, all of the other transactions are dropped. So on chain, as I was saying, it is possible, and it doesn't necessarily have to translate to a DDoS on a mempool if done properly.
Yeah.
And
sorry.
So-
continue.
Yeah, no. What I'm saying is, what I'm advocating for in general is that we should try to think less in a centralized way. So we should try to think less on relying off-chain components of chain side programs to perform what a simple transaction should do.
Yeah.
And instead try to leverage more what is already possible on Cardano, which is a beautifully designed protocol as a whole, and it allows for far more than what has been done so far.
I mean, you still need to filter out. You would still need to have a filter that rejects certain kinds of transactions because unless you yourself are willing to fulfill them, and you have no interest in keeping around a single transaction that there's waiting for someone else to fulfill it, because once it gets fulfilled by someone else, then you'll get the full batch anyway. So this kind of filtering mechanism would have to either be implemented in the mempool or be separate from the mempool, I guess. So
Yes.
but we haven't really considered including it in the mempool. If that is something that is that would make this a more kind of palatable approach, that is definitely a topic worth discussing on the CIP. But at this point, I can't tell you if that is something that we can make happen or not off the top of my head.
What I'm suggesting is that this filter mechanism is already present. It should not be implemented. It's already there. It's not directly in the mempool. It's more in consensus.
Yeah.
As soon as a block does include one UTXO that is spent in a transaction that is pending in a mempool, the transaction must be dropped for that block for this subsequent ledger state.
Yeah.
And then in case of rollback, then the ledger state is reconstructed, and so that transaction could be valid again.
You're right in that it's present, but this would be like a different kind of filter. That's not just applying the ledger rules to see if the transaction can still be applied.
Yes. Okay, I get it.
I'd like to hear, Matheus, do you have any thoughts on this? Because I know you are also pretty technical as well. Any thoughts on this? Just hearing the discussion?
Well, I have some thoughts, but they are actually coming back more to the basics. Like, would we still have a situation that we are not charging user for transactions? That this question has not been answered by anybody in this group. If we implement CAP 118, or at least if it has been answered, then I didn't get it. Have basic questions, to be honest.
Okay,
What is the
Polina.
question?
Sorry, I did not catch that. Can you repeat the question, please?
So apart from this, for instance, example of a DApp sponsorship, right? Let's talk
Yeah.
about like an atomic swaps, like classical AMM dexes. Let's forget about all this amazing but exotic use cases, right?
Yeah.
Would we actually have a situation that the user wouldn't be charged for failed transactions if we had CAP 118 fully implemented? I don't think it has been answered.
So, as before, transactions that are phase 1 valid but phase 2 invalid. So so on chain you always collect fees for phase 1 valid but phase 2 invalid transactions, but you never collect fees from transactions that are phase 1 invalid. Because there's no way to do that since they're not constructed correctly. You don't even run the scripts in those kinds of transactions. And in the case of Babel fees, as somebody who would run or the nested transaction service that would listen on the network for incoming incomplete transactions, you could require that. So the whole batch has only one transaction that provides the collateral for failing scripts. However, you as somebody that runs the service can filter out transactions that don't provide their own collateral. Because we designed the system in a way that incomplete, unbalanced transactions that, however, correctly provide collateral can still be posted. So if you don't want to waste your time validating scripts that might fail and then not get paid for it, you can say that I don't want transactions that don't cover their own collateral. However, if you really want to engage with people that really are not providing that don't have any ADA and therefore cannot include collateral in their transactions, in that case you can take that small risk of using a pretty small amount of your computing power to check a failing script and then throw away the transaction even if it fails. But still, at no point are you forcing people to pay for transactions that. Oh yeah, so you only pay for failing scripts, and you only pay collateral for failing scripts.
So we do pay if it failed.
Yes, as before. As before, a batch necessarily pays if there's a failing script in the batch. You necessarily have to pay the collateral is collected at that time. This is similar to how it was designed before. However, poorly constructed transactions that you don't even validate scripts for don't pay because
This is phase 1 then.
Yeah, exactly. Yeah.
Okay, thank you.
Interesting. By the way, if you're just joining us here today live, we're speaking with community experts. We are speaking with SIP authors Polina and Will from IOG. We're here with Michele from Harmonic Labs, and we're here with Andrew Westberg, SPO and developer as well. We're discussing the topic about nested transactions. If you have questions, please feel free to put them in the chat. Interact with the experts, basically. Make sure to get your questions answered today. I can see we do have a question here from Michele Pisenberg. So Michele is asking, it seems to me that for nested transactions, it seems to me that for nested transactions that are meant to interact with one specific protocol, it is a really elegant solution. Okay, that's not a question, but would you say that's a correct statement there, Polina?
For nested transactions that are meant to interact with a single protocol, I am not entirely certain what is meant by that, but so nested transactions, every single transaction in a batch of nested transactions necessarily has to consume scripts or consume UTXOs that are already on the ledger. So you can't chain a bunch of you can't chain multiple steps of a contract together into a nested transaction, because that creates that allows us to kind of generate tokens out of thin air, basically flash loan related problems. So you can generate a token that is indicating that you have a permission to do something, and then use that token, and then it disappears into thin air. Like if we had allowed chaining in that way, that could have been possible. But however, we don't, and therefore you can't interact with one smart contract in multiple steps. So if that's what you mean by single protocol, then unfortunately no. However, you can interact with multiple protocols quite well.
Okay. It says here, maybe to rephrase Matus's question, does this proposal change any of the phase 1 and phase 2 checks?
Yes, it does. Basically, the overarching theme of our design is that the checks that were done on a single transaction are now done on the batch. So the check that there's enough fee, the check that there's enough collateral, the check that the transaction is balanced, and so on, and whether required scripts are present. Those checks are now done on the batch. So that's kind of like the main theme of the changes to these rules. So you only sign your transaction, but then the batch gets checked.
I have a question if it's possible. So thank you for explaining this. This makes more sense now. But it's related to nested transactions. I don't really know if we want to go down this rabbit hole, but I've been exploring like half a year ago or something like that a use case for nested transaction. I've been even wondering if it even exists. Obviously, it doesn't. But even if it would be implemented, I never understood what it would mean to finality and how those transactions would reference each other, because we could basically store more data per transactions. Like right now, we are limited to 16 kilobytes. But then if we put a reference to another transaction, or how that would be implemented, well, how it would affect finality would there be a link to just another transaction, like a linked list or something? Like, if you could comment a little bit on that, or if it's appropriate, Denicio, I'm not sure if it's not too much down the rabbit hole, but I think this is also interesting in a way.
Sure. Who would like to take that? Andrew, do you have any thoughts about this?
No, not on that particular topic.
I think I can answer that, even though I didn't write the CIP. If you scroll in the CIP, there should be a CDL specification. And in the CDL, it specifies how it adds 4 new fields, and then the transaction stays essentially the same. It adds a swaps field, and the swap field is defined recursively as an array of transactions. So essentially, what happens is that we are building, we are leaving space for a transaction to include in itself another transaction. So the limit on maximum transaction size is still the same. So you can have many small transactions. The thing is, yes. So regarding finality, as Polina was mentioning, all of these building of this huge transaction potentially. I will call it. It doesn't have to be huge, but huge because it contains others. The building of this huge transaction never, while it is being built, it does never goes on chain, so it does not affect finality. Once it has been built entirely, so say you have a transaction built in pieces, and so you have a proposal for a swap, you have a party fulfilling that proposal, and then you have maybe a party providing the Babel fee. So you build three sub steps of transactions, then that is completed. And once all of this is put together, only then goes on chain. So and that is why there was my concern for centralization. You have to send all this information to a single party or a few parties that are building a transaction, this big transaction. And so once that is completed, then it goes on the chain.
Yeah, that is true. I just want to point out that a DEX aggregator also would be waiting for a bunch of transactions with that would attempt to aggregate. And this allows swaps before. A lot of the swap use cases, I imagine, especially the Babel fee use cases, would involve two parties at most. So if you send out your incomplete batch or your one transaction, whoever sees it and decides that they would like to engage with it, if they have a nested transaction service, it would hopefully inform them of that, and they will be able to post it on chain. So it's not necessarily you're sending it to one specific party. You're kind of like the idea is you would disseminate it like you would Cardano transactions, however, on a separate network.
Well, interesting. I think we have time for one or two more questions, and there was a follow-up question, by the way, by Michele, and he said here, and is it also possible to do any phase 2 check before gathering and completing the full batch?
You can do all the phase 2 checks for all the transactions except for the phase 2 check of the script that runs on the whole batch. So if you add a script that's supposed to validate the entire batch, you can't phase 2 check it until you've made the whole batch. And this script is kind of like specifically for that, to say the entire batch does something or has certain property or something like that. For the normal scripts that, just you're spending a UTXO, you can do the phase 2 check locally as before.
Okay. I'd like to really kind of wrap it up a little bit. So let's go back to that, let's say, famous tweet. And if I may share that, Sebastian, where we all started. Andrew Westberg. I don't want Peras. I don't want Leios. I want nested transaction first and foremost. Now, speaking to the SIP authors and getting a better understanding really of the nested transactions, the use cases that it unlocks, what it all entails. Now, I do know and I do believe, Andrew, you already had somewhat a good understanding of nested transactions. Having Polina and Will here explaining certain things in somewhat detail, how does that change your opinion on this? Does it change anyway, or
yeah,
not?
I think it does a little bit. My goal is similar to what Michele's was. Like, we don't really want batchers. We want decentralized everything. What nested transactions does give us is maybe easier to build batchers, possibly a little more decentralized, but we're still, at the end of the day, assembling these things off chain with some other process. Whereas, other chains, account-based models, they can kind of truly be decentralized and do the whole intent of the thing they want to do. There's other disadvantages, but I guess what I'd like to say, if we're closing, is where we want to go is where there's no nobody between you and the intent of what you want to do on the chain. There doesn't have to be a process on the other side of a particular protocol to interact with that protocol. Like, the protocol should deploy on chain, and you should just be able to interact with it without interacting with any other processes or third-party stuff. That's where I think we want to go. I think nested transactions takes us a step in that direction, but it doesn't seem like it gets us all the way there.
Right. I definitely see what you're saying, and I think it would be, hopefully, it would maybe take it a step further in that direction if the mempool itself was capable of supporting incoming transactions across the chain that are incomplete and still need to go in batches, and then you could just tune your mempool directly.
Or like, even let's say the protocol, it came across, I see a partial transaction. It doesn't have to hold that in my mempool, but maybe it tosses it off to the side to another process that I choose to operate, where I can choose what filters I want on that, where I can throw out old stuff if I want to, things like that, where it doesn't pollute the main mempool. But just an idea I'm throwing out there.
Right. I mean, so like you would like to use more of the Cardano network for this, for the fulfilling the goals of what
I think so. I think that gets us closer to where the account models are without their disadvantages.
Mm-hmm. Yeah, that makes a lot of sense.
Michele, before we close, Michele, I'd love to hear from you. Any final thoughts? I saw you're agreeing with Andrew, things that he said, but I'm pretty sure you have some final thoughts, please.
Yeah, no, what Andrew said in this case also is great. We definitely want to possibly have as much just interaction between me and the contract, and do not expect someone else to complete the valid transaction for the chain as a third party that might be designed to be decentralized, but ultimately at least all the cases I saw lead to centralization. I don't think any of us is here to see centralization. Otherwise, I don't know, banks were great. Yes, my main concerns are exactly thinking on the application level, how we can stay decentralized, how we can stay trustless, how we can not depend on third parties, and also all the core principles that spawn up this whole cryptocurrency thing. So the thing is, I'm not happy for how it is designed. Of course, I'm just a voice between many. But yes, I would say already having something that is handled on the mempool, that is partial transaction, as we were hinting now, would be a better solution, but I would not even consider that as a final solution because of the DDoS problems that it may cause that were raised validly. So yes, I would suggest we take different approaches entirely to developing applications. And as for this now, this is only a technical opinion. I wouldn't want to see this implemented on the main chain. It could be a wonderful implementation for application-specific chains, but I wouldn't see it implemented on generic purpose applications such as Cardano.
Yeah, thank you for sharing that. Will, love to hear from you as well. Any closing thoughts, final thoughts from yourself?
I think there've been great points made. I think there's obviously potentially stuff to discuss on the CIP and possibly in follow-up calls, I guess, if people want to have follow-up calls. I think there's obviously lots of great ideas, and I think there's probably going to be some optimal solution that everyone can agree on, and we can improve Cardano.
Yeah.
Thank you. Absolutely. Matus, any final thoughts from yourself before we close?
Well, not much. Maybe we should have mentioned more what Peras and Leios is about for some people that might not know. I would also disagree with you, Andrew, that this is just for midnight. There are, yes, within the partner chains or side chains, there are quite a few of them that are being worked on, but it's not just for midnight. So just I wanted to clarify this. And even within what I'm currently working, I would really benefit Peras. So I think the fact that we are just disconnected from each other's use cases sometimes means that we do not fully sometimes comprehend how it would really help another team, which could be its own roundtable sessions, to be honest. But I do not think Peras. I think Peras is actually quite useful. I'm looking forward to it. And it's also more low-hanging fruit than Leios is, which is a much bigger fish to fry. So yeah, that's my.
Yeah, thanks for that. I do want to allow Andrew to comment on that, though. Andrew?
Sorry, trying to find the unmute button. Yeah, I have my own perspective on, it to me, Paris seems like a lot of work for not a lot of benefit. So what we get from Paris is we get faster finality, but it's still not like finality. It's still only just like a tinier window where we have a smaller percent uncertainty that something is truly final. So I think we need to weigh the costs and efforts of such a thing versus just like, okay, when somebody moves value over to midnight, they wait a little longer and we don't do Paris. Or we do Paris and they can be a little more sure that that transaction is final and they can move that value a little quicker. There, as with anything blockchain, I think there's trade-offs and we need to weigh costs and time and efforts and complexity into all of that stuff.
Amazing. Thank you so much there. And thank you so much also to the viewers who's joined us today during this live session. Thank you so much, Andrew, Polina, Will, Michele, Matus. Thank you so much also in the background, Sebastian, for taking care of this wonderful session. And yeah, again, this is an educational roundtable talk. That's the design of it. It's there to empower, to educate, and enable the community, Cardano community. So until next time, thank you so much.